and welcome back to Intermediate Algebra. Today we're looking at section 3.5 and we're going to start looking at functions. So functions are a really important piece of math and we're going to kind of slowly take our way through just a general understanding of them here, and then in the coming sections we'll kind of dig in a little bit more. So a function, we're going to start with the definition, and if you don't understand the whole thing, that's okay. Watch the rest of the video and then come back and look at the definition again if you're still kind of confused. So a function is a rule that pairs each element in one set called the domain with exactly one element from a second set called the range. And so we're going to hang out here on this board for just a little bit. I'm going to talk through an example and kind of talk about domain and range just a little bit, and then we'll kind of solidify some of those terms here in just a minute. So here's my example that I want to think about. You make $10 an hour at your job, but you can work no more than 40 hours per week. Okay, so here's what we want to kind of think about here. A function is this connection, if you will, this rule that connects two things. In this case, the function is going to connect how many hours you work in a week with how much money you make. Okay, and I think this is something we're all at least kind of familiar with. Most of you, I'm sure, have had a job at some point. So here's my rule, if you will. Y is equal to 10 times x. The amount of money you make is equal to $10 times how many hours you work, right? That's kind of straightforward. We hopefully we all know that one. In this case, x is my domain variable because that's the numbers we're going to be plugging in. If you were working a job and you wanted to figure out, you always want to know how much money am I going to be making. You would plug in the number of hours you worked. You wouldn't plug in how much money you made. You would start with the hours that you worked. And so x here is our domain variable, and it would be the number of hours you worked. The range variable is going to be y. That's the output. That's how much money we made in this given week. So our domain here can be x is anywhere between 0 and 48 hours. Now, obviously, you can't work less than 0 hours. That just is not something that works. And in this case, because, let's face it, your boss probably doesn't want to pay you overtime, you can't work more than 40. So you're stuck between 0 and 40. Our range is from 0 to $400. Where did I get that? Well, pretty simply, I just plugged in 0, which if you don't work at all, you don't make any money. That makes sense. And if you work the maximum 40 hours, 10 times 40 gave me the $400. So we have this connection here. The domain is all of our values that are going to be plugged into the function. The range is all of the values that come out of the function. But before we go on from this board, I want to come back to this definition for just a second and look at a couple more pieces of it. All right, so we have this definition. It's a rule that pairs each element. Okay, we have this equation over here that we use to pair hours and money made. Great, got it. But here's the rest of it. Each element in one set called the domain, okay, we're still working on that, with exactly one element from a second set called the range. And what I really want to zoom in on here for a second is this exactly one. Okay, here's kind of where we're going with this exactly one. If you work some number of hours, you expect to get paid. Right? There is going to be money coming for you at the end of whenever your paycheck shows up. So you expect that there is something that your domain variable is paired up with, right? If you work 10 hours, you expect to make $100, right? So there has to be something that you make. You can't have a domain variable you can't work some number of hours and not get paid at all. That's not a thing that happens. So every element of the domain needs to be paired up with something in the range. Okay, you can't have any domain variables that don't have a pair. The second part of it, though, is that exactly one. Each domain variable can only be paired with one range variable, and this is really important, especially if this is your job, right? If you work 20 hours in a week, 10 times 20 is $200. You want to know that if you work 20 hours, you're going to make $200. You don't want to be left guessing how much money is going to be on your paycheck, right? You don't want it to be $200 this week and then, you only make $50 next week. That's not how this works, right? So with functions, every domain variable has to be paired up with exactly one range variable. And that's just the way it's going to have to be. Okay, you can't have a domain variable with two outputs. That's not a thing. Now it's going to turn out that you can have a range variable with two inputs. We'll talk about that later. But for now, you can't have an input with two outputs. If you put a number in, you should know what's going to come out. If you work 20 hours, you should know how much money you're going to make. All right, so let's move on. All right, continuing on. Just to solidify the domain and range. There we go. I can't talk. Just to solidify the domain and range, a couple of definitions. The domain is a set of all input values. Again, these are the numbers that are going to get plugged into our function. It's frequently x. Not always. If you were, for instance, working in, say, physics, time is often the domain variable, and that would probably be a t. But a lot of times it's going to be x. And the definition for range is that it is the set of output values. And again, that's frequently y. So some ways that we can write functions, and I'm going to have to continue this on the next board too because there are more ways, but here are the first three. So I'm using the same function that we were just looking at on the last board, where you're making $10 an hour. So we can write a function as a rule, where in this case it's y is equal to 10x. Right? This is a description of how these things get paired together because, you know, if you pick a number for x, the y value automatically comes with it. You can write a function as a set of ordered pairs. Okay? So here are, these are just three ordered pairs that would work with our previous function. If you work 0 hours, you make $0. If you work 10 hours, you make $100. If you work 20 hours, you make $200, right? Because you're at $10 an hour. Now, obviously, there would be more ordered pairs, so this isn't really quite sufficient. You would need a really big list of ordered pairs for this. You could write it as a table of values. Okay? Remember, domain is always that first variable. So in the ordered pairs, 0, 10, and 20 are the domain values, and in the table, the 0, 10, and 20 are still the domain values. All right, so let's get another board and look at some more ways to write a function. All right, so our last two ways that we can write a function, we can use what's called a function map, and these are just two ovals. And in the first oval, we have the domain values, and in the second oval, we have the range values, and we have arrows showing what domain values go where. And then the last one is we can make a graph. So again, these are both still for the example where you're making $10 an hour. With the graph, you can see the domain values are along the bottom, the x-axis, and that's where we're always going to put those domain values, even if we're not using x for domain. Okay, if t was the domain, this axis along the horizontal axis is always the domain axis. And then the vertical axis is the range axis. And so you can see for each input, we have an output. And so it's important. You're going to need to be able to recognize domain and range when you're looking at a graph. And just keep in mind, the domain is all the inputs, it's all those horizontal values. And so any x value here works. Now, notice that we stop at 40, right? 40 is the last x value, which makes sense because you can't work more than 40 hours in a week. And so, but we should be able to read the graph to figure out what those x values are that we're using. Same thing with the range values on the y-axis. All right, so let's look a little bit more at some functions here on the next board. All right, so now, is it a function? I have three examples here, and we're going to look at all three of them, and we're going to try and decide, do each of these examples represent a function or not? Okay, pretty straightforward. Remember, the definition of a function is every input has exactly one output. Okay, that's the definition. It has to have something paired with it. These all have something paired with it, so that's taken care of. But it can only be one thing that's paired with it. So let's take a look. First example. You notice that all my domain values are different. That pretty much guarantees it's a function. Because remember, each thing here each x value has to have a y value paired with it. They all do. And all the y value, and each x value can only be paired with one y value. Well, 0 is only paired up with 5. Okay, and you can check the rest of the chart, but each x value is only paired with one y. So that one is a function. So what about the second one? Here I have all different x values, 0 through 4, but my y values now are all the same. So this one frequently messes people up because those 5s there in the second column are really designed to kind of be tricky. But here's the thing. Is each x value paired up with something? Yep, every x value we have has something in that second column. Is each x value paired up with only one thing? Yes. They're all paired up with the same thing. This is a really boring function. It's actually what we call a constant function. Whatever you put in, you get 5. But that's okay, because the definition just says every input is paired with exactly one output. Pick an input, 2. How many things is 2 paired up with? Just 1, just with 5. That's it. So even though we have that column of 5s there in the y, for the y's, it doesn't make any difference. It's still a function. But this one is not. Why not? Well, the big giveaway is that we have repeated x values, right? I have 0 and 0, 1 and 1, and then I just have a random 2. Well, if you look, my 0, what is 0 paired up with? 0 is paired with 5, but it's also paired with 6. That breaks the function. It's not a function anymore. This is a relation. A relation is less picky. It's just a set of ordered pairs, basically. But here, this is not a function because, if you think back to the example of how much you work or how much money you make for working, you don't want to kind of have to guess how much you're going to get on that paycheck, right? You worked 20 hours. You want to know that you made your $200. No guessing. So this is not a function. So remember, you can have repeated y's, you can't have repeated x's. All right, so I want to continue our discussion of is it a function or not? And to do that, now we want to look at the case where we have graphs. Because there's actually a really easy way to look at a graph and tell if it represents a function. And it's called the vertical line test. The vertical line test says that given a graph, it represents a function if any vertical line only intersects the graph at most one time. Okay, it can miss the graph entirely, that's okay. But if it hits the graph, it can only hit it one time. And so let's come over and look at these two examples that I have. In the first example, we have this nice smooth curve here. It's probably a third-degree polynomial, but you may or may not care about that. And what you want is to just pretend that you're dropping a vertical line through it. Importantly, this vertical line needs to be able to move all the way across the graph, left to right. You're just going to kind of picture this in your head. Well, is there anywhere you could draw that vertical line where you'd hit the graph more than once? No. So this one absolutely represents a function because that's what the vertical line test says. Any vertical line only hits the graph once. And again, that makes sense because this vertical line represents a specific x value. Okay? And so if your specific x value only has one y value, that's our definition of a function. As opposed to this second one. With this second one, it's pretty easy to see that there are a lot of vertical lines I could draw here that would cross the graph twice. Again, what that means is we have an x value with two y values, and we can't have that, right? Each input gets exactly one output. So these, the vertical line test is a great way to tell if your graph represents a function or not. And rather than erase this board and write more stuff because I don't really have anything else to write, the last thing I want to talk about is how do you graph a function? Well, there are lots of tricks that we have as math people, but for now, if you don't know how to make the graph of a certain kind of equation, just make enough points so that you really have a pretty good idea of what that graph looks like. And if you have a graphing calculator, that would be a useful place to use it to kind of get a better idea of what that graph looks like. So that hopefully you don't have to throw 20 points at it to figure it out. But just plug in a bunch of x values and see the y values that go with them. And there you go. Good luck.